Okay, so the recording has started and we'll post the recording on Discord. So just to sum up, in the last workshop, we went over the first page. And the first page is just basically about solids of revolution. And then we took a look at finding the work to pump water out of a tank. So that's the first page. Today, we're going to go over the second page. And it has to do with improper integrals. There's the comparison test. And then you also have to calculate the hydrostatic force when you put the shapes underwater. And then there's also calculating the centroid. Okay, if you guys have any questions, feel free to turn on your mic and ask. And if there's any question you want me to go over again from the last workshop, I'll be happy to. Okay, so let's get started with the first question, which is to find the average value of the function, this one, in the interval from 1 to 4. And it's actually very easy. All you have to do is just plug and chug it into this formula. F of c is equal to 1 over b minus a times the integral from a to b of f of x dx, where f of x is this guy right here. Then a is 1, b is 4. So as you can see, it's very easy because you can just plug in the numbers. So b is 4 minus a, which is 1, then the integral from 1 to 4, and then we have this guy right here. So this will give us 1 over 3. And then from the first fundamental theorem of calculus, we can make this into f of 3, or rather f of 4 minus f of 1. So the next step is to calculate the antiderivative f of x. And that's the integral 1 over the square root of x times x plus 1. Okay, I see there's one question in the chat. Did we do 4 last time? Yep, we went over up until here, so we haven't done number 4 yet. So this one's pretty simple. All you have to do is say let u equal to the square root of x. So I'll write it like this, and then you find the derivative of both sides. You get 1 over 2 times x, like this. That's basically the same as 1 over 2 times the square root of x. So when you multiply, you do the proportional fraction, right? You multiply this with this, and then you multiply this one with this, and that's basically how you end up with this line right here. So notice here we said that we let u is equal to the square root of 1 over 2. This is x to the power of 1 over 2, right? Therefore, we can write it like this. We can write it as 2 times u du is equal to dx, because we said that u is equal to the square root of x. We just change that to u. Okay, let's plug things in. One over u times x plus 1, and dx is 2u times du, so 2u times du. Now the u's are gonna cancel out, so this u will cancel out with this u. And then what we can also do, so let me write it again. So 1 over x plus 1, this is times 2. We can move the 2 over here because it's just a constant, times du. Now we also have to change the x into the u. Now let me show you how to do that. So here we know that u is the square root of x, right? This means that u to the power of 2 is equal to x. And then if you recognize this from your trigonometry integrals, this is basically the same as 2 times the arctan, right? So tan, this is the arctan of u plus c, and that's the antiderivative. So we successfully found the antiderivative f of x. Okay, are there any questions before we move on? Okay. So the final step is changing the u back to the x. So this is equal to 2 times 10 minus 1. So u is the square root of x. You can write it like this, plus c. The next step is to find f of 4 and f of 1. So if you guys are finished, I'm going to erase this. Well, so what is f of 4? We just plug it in. So 2 times 10 minus 1, and then 4 to the power of 1/2. That's basically 2. Then we have f of 1. That's equal to 2 times 10 minus 1, and that's 1 right there. So if you use your calculator, you should get the final answer. And that's 1/3 times 2, 10 minus 1, 2, minus 2 times 10 minus 1, 1. And just put it into a calculator and you will get 2/3 times 10 minus 1, 2, minus pi over 4. And I would just erase this. So finally, that is the answer to this question. So there's a question that says on the quiz, we would just put the decimal version. Yeah, that's up to you. If they allow you to round to, let's say, like the second or third decimal. But the safest way is just to put the answer like this, so you don't have to round anything. So that's it for this question. Are there any concerns? Maybe any step that I can clarify? No? Okay, looks like we're ready to move on to the next one. Now the next one is about convergence or divergence. So this question says, use the definition to determine whether the improper integral converges or diverges. If it converges, then we find its value. So you can just solve this integral. And if you remember the improper integral, we get the limit as t approaches 2 plus. And why is that? Because we are approaching from the right side, right? If you're approaching from the right side, then it's 2 plus. If you're approaching from the left side, then it's going to be 2 minus. From the first fundamental theorem of calculus, then you just get the limit as t approaches from the right side of 2, you get f4 minus f2. Our job is to find the antiderivative, which is the integral 1 over the square root of x minus 2. This one is also very easy to do. We say let u equal to x minus 2. So du over dx, the derivative is just 1. Therefore, du is dx. And now we found the antiderivative. We just put the x back. So that's it. That is the antiderivative of f of x. Before we find the f4 and f2, in order to find if it converges or diverges, are there any questions regarding f of x? Let's see, there's one question in the chat. Somebody's asking about taking the ln for 1 over something. I think that it's better if you do it this way, because if you can avoid the ln, that would be better. The ln can sometimes be very overwhelming on exams, but if you can just simplify it using this way, then it's going to be better. Okay, seems like there are no more questions. I'm going to erase this. Now, what is f at 4? What is f at 4? Well, you should just put the 4 in. So 2 times 4 minus 2 to the power of 1 over 2. That's 2 times the square root of 2. How about f at 1? That's 2 times 4 minus 1 to the, no, actually, this is 1 minus 2. Oh, sorry, this is f of 2. I saw f of 1 for some reason. I'm just gonna move this over here. There we go, that's much better. We have more space. So f of 4 is going to be this. And then we minus f at 2. But instead of doing f at 2, because we say here the t limit is approaching to the right side of 2, we should have written this as f of t instead. This is actually f of t. Right, because t is approaching to 2 anyways. So let's find f of t. So putting f of t in, we're going to get something like this. And now the final step is very simple. So as t approaches 2, what's going to happen? Well, as t approaches 2, then this will be 0, right, guys? Do you guys see? This will just be 0. Because when t approaches 2, then this is 2, 2 minus 2 is 0. So the final answer would just be this. Since we have a final value for the integral, it means that this converges. Are there any questions?
Wait, sorry. I wasn't here. Why is it f of t?
Yeah, let's see. Well, so we said that here is the limit, right? The limit as t approaches the 2 from the right side, you're going here. Because basically what this is, if at this point it is a, what is it called again? Like it's a divide by 0. You see, if we put 2 here, then that's going to be divided by 0. So that's why we say the limit as t approaches 2 from the right side. So give me 1 second. This would actually be t right here. And then using the first fundamental theorem of calculus, this would be f of 4 minus f of t. Like that's just the fundamental theorem of calculus.
Okay, thank you.
Yeah, no worries. There are 2 more questions in the chat. Yeah, you're right. It's actually a t here instead of a 2 because I replace it with the t. I define the t right here, so this should actually be a 2. And let's see the other question. Is there any reason to set the limit before finding the function's antiderivative? I mean, this is the only way to solve improper integrals, which is to do the limit. That's the only way that I can think of. So how can we know what is an improper integral? Well, if you look at the limit, here's the trick. If you look at the integral here, it goes from 2 to 4, right? So if you put a 2 in here, you know that's the divide by 0, and that's when we know that this is improper. Okay. Looks like we're ready to move on to the next question. The next one is also going to be about convergence. So we use the comparison test to determine whether each of the following improper integrals is convergent or divergent. So as you can see, the first one is improper because we have infinity, right? When you see infinity, that's improper. Now the second one, why is this also improper? That's because you see that the limit goes from 0 to 1, right? That's the bounds on the integral. And if it's 0, then this would be also divided by 0, as you can see. So that's why it's also improper. And when it's improper, we need to find whether it diverges or converges. So let me show you a very easy trick for this one. All you have to do is graph this one. So after I graph this one, you see that this is the yellow function right there. You can just like plug into your calculator and find the values and graph it like this. And you can also graph the function y is equal to 1 over x. So there is a rule in the textbook that says that 1 over x is convergent, right, guys? Remember 1 over x, the limit like this. This right here is convergent. Do you guys agree? So if the red function is divergent, oh, excuse me, I said divergent, but I wrote convergent for some reason. So this is divergent. This is divergent. So 1 over x is divergent, which means that any function above it is going to be divergent as well. Yeah, you guys are right. I said divergent, but for some reason my hand writes convergent. You know, sometimes I think my hand has a brain on its own. Yeah, but you guys are right. This is divergent. So if this is divergent, then any function above it is going to be divergent, which means that the answer for this one is divergent. So for A, it is going to be divergent. Someone asked, is there a way to do this without using the graph? There is another way, but this one is the easiest that I can think of. Like, there are many different ways to determine if something is convergent or divergent. This is the simplest way. Oh, someone asked, I don't know how we're going to do the graph mid-exam unless decimals is allowed. I mean, you guys have the calculator, right? Even though it's not the graphing calculator, you can use that to determine the values and graph the function on paper. So just graph it on paper, guys. Like, you can just do something like, you know, for f of 1, what's the value of this? Then f of 2, what's the value of that? F of 3, and then just do like a mental calculation, and you'll get that graph. So let me summarize this. Let me summarize what I just did. Oops. Something happened. Okay. The rule is if a function is divergent, then anything above it is divergent. If a function is convergent, then anything below it is convergent. Okay, can someone asked, can I explain how I got 1 over x, right? It is just the, this is called like the p-series test, p-series test. I think that's what it's called, p-series test. So if you have an integral that's improper, you can use the p-series test. So just plug in 1 over x to see if it's above or under. If it's above, then it's divergent. That's just the test method here. Okay, let's move on to the next question. So the second question, I won't use the p-series test because someone asked if there's a different way to do it. So I'll do it using a different way. We have to determine whether this one converges or diverges. And the easiest way is just to solve this. Okay, so as mentioned before, this is an improper because of the 0 here. If you plug in the 0, it's going to be divided by 0. For that reason, I'm going to do limit as t approaches 0 from the right side of the integral t to 1. Then we get this. So using the fundamental theorem of calculus, we get the limit as t approaches 0 from the right side. Then we get f1 minus ft. Okay, someone asked, it says we have to use a comparison test. Yeah, I mean, the last question I used a comparison test, but someone wants me to do it using the different way. So I'm just doing the demonstration for both methods. Okay. So you have to find the antiderivative. This one is like the last one, actually. We can say let u is equal to the square root of x, then du over dx is 1 over 2x, like this. Okay, and instead of writing like this, we can write it as 1 over 2 square root of x. This means that 2 the square root of x du is equal to dx. And since u is the square root of x, then we can write it as 2ud is equal to dx. Okay. We can just plug the u in here. So 2u minus u squared, then dx is 2 times u du. We can factor the u out here. So let me factor it out. Now, first of all, we'll move the 2 to the front because it's only a number. We can move it. The u is going to cancel out here. Okay. Now, by this point, we have to do another substitution. And I'm going to erase this to get some more space. Okay, let me see. I'll actually erase up to here. Okay. So here we say let v is equal to 2 minus u, because we want to change this to a v. The antiderivative of that is just ln, right? It's actually and why is there a minus sign here? Well, that's because I'll show my work here. That's because we say that b is equal to 2 minus u. So dv over du is equal to negative 1, right? And for that reason, dv is equal to du. And so when we plug it in here, when we plug it back in here, this becomes a v. That becomes a v. And then what happens to the du? Well, here we found out that dv is equal to minus du. So du is equal to negative dv, right? So this becomes a dv, but then we also have the minus sign here because it's negative, right? We actually will put the minus sign up here. And that's how I ended up with this. If it's easier to see, I'll write it like this. And then we get to this part. Does that answer your question? You might want to plug in your computer. Oh, okay. Oh, you're right. Yep, that's a good catch. There you go, I plug it in. And then what do we have here? We have minus 2 times ln v plus c. That's the same as minus 2 times ln 2 minus u plus c. And we just put the u back into our original variable, which is x, right? So that's equal to negative 2 ln 2 minus the square root of x plus c. And I'll actually erase over here to write it more clearly. So this is going to be 2 minus square root of x plus c. So this right here is the antiderivative for our function. And the last step is just to find f1 and ft and plug it in. So before I do that, are there any questions? No, no question. Okay. All right. Now the last step, we have f of 1. What's f of 1? That's going to be 0. What is f of t? What is f of t going to be? Well, f of t will be negative 2 ln 2 minus the square root of x. And we change the x into the t because here we say it's t, right? So that's going to be f of t. That's the same as the plus sign. So the limit 0 approaches this side, then this is going to be 2 times ln t minus the square root of t. So what happens when t approaches 0? Well, as you can see, this will be 0. This thing will be 0. Or you can just plug the 0 in. Like, you can totally do that. And then this thing will be 0, is what I'm talking about. This thing right here. Then we get 2 times ln of 2. And because we have a number at the end, we know that this right here is convergent. It's going to be convergent. You also got 2 ln too. That's pretty good. Yeah. Are there any more questions? I think it should be 1 over the square root x is equal to. Could you turn on your mic and show me what you mean? No, it wouldn't be 1 over 2 square root of 2x. Like, I don't see how you can get that.
Hello?
Yeah.
Yeah, so for like the practice midterm sent by my teacher, he used the comparison test, which was like, oh, in this case it would be like 1 over 2 square root x minus x is less than 1 over 2 square root x, right?
Mm-hmm.
Yeah, so on interval 0 to 1, 1 over square root x converges. So therefore it has to converge or something like that.
Yep, that's definitely one way to solve it. Again, like I said, there are many different ways to find if something is convergent or not. Like I remember until the second midterm, you guys will learn like 8 to 9 different ways to determine if something is convergent or divergent, and this is just one of the ways. So one way is you can just solve it. You can use the comparison test, or you can use any method that you want, as long as you get this number right here, then that's the correct answer. So this is the correct answer from the solution, and if you get this, then you got it. Okay, so if there are no more questions, the next one is going to be about finding the arc length. It's going to be finding the arc length of a function, and I think this is my favorite part because it's very easy. And wow, we're on question number 7 already. It's going pretty quick today. There are only how many questions? 9 questions in total. So we'll have plenty of time to go through this one. There's a question about will we have more exercise covering hydrostatic forces and work? There are 2 questions. In the last midterm, in the last workshop, we covered this one, which is finding the work to pump water out of the tank. If you guys want me to go through this one again in this workshop, I'll be happy to do so. And then there's also this one, which is about calculating the hydrostatic force. Yep, we'll go over the one with the volume, definitely. It's actually very easy. Now we have to find the arc length, and there's a formula. You can just plug and chug in it. So first of all, you're given this interval, right? Which means that A is equal to 1, B is equal to 4. So this is A. Oh, 1 second. This is 4. So this is here is A. That here is B. So you just plug it in. This is 1. That's 4. Then you get the square root of 1 plus the derivative, like this, to the power of 2 dx. So what is f of x? Well, we're saying that this one is f of x. Right here. Now looking at this, the first step is to find f prime. Yep, so I found f prime. Someone said about the washer and cylindrical, which method to use. There's a trick to that. We'll go over it later. Okay. So this is for, that's going to be 1, 3 over 2x. Instead of writing this, I'll put the 1 here first, right? So plus, and we put this in. Okay, you guys okay with this? I'm gonna erase this here. The next step is to find this one. This is to the power of 2, so we want to expand that. Let's see what that's going to be. Remember, there's an easy way. So a plus b to the power of 2 is equal to a squared plus 2ab plus b squared. So here you get 3 over 2x like this to the power of 2 minus 2 times this times 1 over 6 plus 1 over 6 square root of x to the power of 2. This will give us 9 over 4x. Okay. Now over here, things are going to cancel out. And then we get negative 1 over 2. So let's see why it's negative 1 over 2. Well, the 2's are going to cancel out. This one will cancel out with this one. And then this is 1, that's 2. So that's how I got 1 over 2 here. And then plus 1 over 36x. So this is after we expand this right there. After we expand that, we're going to get this expression here. Are you guys okay with this? I'm going to erase this for now. I'm not going to erase this line right here. Now we add the 1 to the minus 1 over 2. And oops, this is supposed to be 1 over 2. I wrote it too fast. So this is 1 over 2. And instead of writing like this, I'm going to interchange the spots. So let me show you what I mean. So instead of writing like this, I'm actually going to write it as 9 over 4 x plus 1 over 2. It's really the same thing. But there is the reason why I write it like this. Now we want to make it so that we get this form in order to get this. We want to simplify this into something simple like this. So as mentioned before, we know that a plus b to the power of 2 is equal to a squared plus 2ab plus b squared. We're going to make a squared equal to 9 over 4x, and I'll show you why in a second. And then we're going to say b squared is equal to 1 over 36x. So this means a is equal to 3 over 2, and then x to the power of 1 over 2. Then b is going to be equal to 1 over 6. This is the square root of x. Now you see this right here, C2ab. So let's see what that's going to give us. 2 times ab is equal to 2 times 3 over 2x, like this, times 1 over 6, the square root of x. So here, the 2 will cancel out. This will be 1, that's going to be 2, then this will cancel out. And that gives you 1 over 2. So you guys see what I'm saying here? We get 1 over 2, right? There are 4 questions in the chat. Yep, okay. I didn't see any questions there. So for that reason, we determined that A is equal to this and B is equal to that. There's a trick that I want to show you guys. If you get something like this, where it doesn't look so beautiful, where there's an x here, then there's the x there, just make this a squared, make this b squared, and then you'll find that you plug this into this formula and you get 2ab is 1/2. So that's the trick. Okay, and we're almost done with this question. This will be equal to the integral from 1 to 4. So Ginger asks, when using the trick, is 2ab always 1/2? It can be a different number. Like if you have a different expression, then the number in the middle might be a different number. But to answer your question, in this case, yes, it would be 1/2. So again, like I said, when you see something like this, just set this to a square, set this to b square, then you will get this as 2ab. And then this right here is the same as a plus b to the power of 2. And that's how we got this one right here, to the power of 2. Okay. Continuing on, we get integral for 1, then we just get this. So what happened to the square root? Well, it disappeared because here is the power of 2. And then if you take something like this will be a, right? The square root and the power of 2 will cancel out. So that's how I ended up with this integral. And it's a lot easier than we have in the beginning. Okay, let me get some more space. If you guys are finished copying, I'll get rid of this space right here. And then we'll get rid of this one. How about let's do this one too. And we're almost done. So this one can be rewritten as 1/6 times x to the power of -1/2. The last step is to find the antiderivative. Are you guys okay with me writing it this way? This is the same as saying, that's the same as saying f of 4 minus f of 1. That's really the same thing. Oh, someone asked me, how did you get rid of the square root? Well, I mean, I explained before, if you go back in the notes, we have something like this, and that's going to be this, because the 2 and the square root cancel out. And I'm going to save you some time. Seems like this isn't a hard integral to do. So you're just going to get this plus 1/3 x over 2 like this for 1. So you plug in the 4, you get 4 to the power of 1 like this, plus the 3, 4 to the power of 1/2. Then you minus the lower bound, which is just going to be 1 plus 1. And then after you solve it, you'll get 22/3. So I'm just going to save you guys some work because it seems like this is just like basic algebra. So 22/3 will be the answer for this question, and that's the length. Okay, are there any questions? Feel free to turn on your mic. Okay, so the next one is going to be about hydrostatic force. That's the one you guys have been asking me about. And before I move on to the next question, somebody asked me how did I get rid of the square root. I'm just going to show you very quickly. I believe I sent this on Discord, which is the answer sheet to this whole thing. This is my work. I went through this during the weekend. And let's see where that part was. So here. So we got this, right? We got this. And then we did some magic, some algebra magic. We got this. So the square root and the power of 2 will cancel itself out. And that's how we get rid of the square root. Does that make sense? Rahul, does that make sense? Okay, perfect. Okay, moving on to the hydrostatic force one. So I'll read the question. Actually, before we do that, let me pick this one and move it to the top a little bit. There we go. That's much better. So this question, it says, a disk of radius 5 meters is partially and vertically submerged into water such that the center is 3 meters under the water surface. Let h be the depth of a horizontal stripe of the surface. Express the force in newtons acting on the surface as a definite integral of a function of h. The density of the water is p, and the acceleration is g. Now this one's very easy. There's a formula you can just plug into it. Now, first of all, I've drawn this diagram. It's a circle partially submerged. So that's why you see that this is the water level. It's not submerged the whole way. And then we know that the radius is 5. The radius is 5 right here, which means that this point is going to be minus 5, right? Because from here to here is 5. The radius is 5. I have defined h to be in this direction. It's just like the y direction. But instead of y, I'm going to write h because that's what the problem wants. And then this is going to be the x-axis. Now, here is the tricky part. This is our horizontal stripe from here to here. You can pick any stripe you want. It doesn't have to be here. You can pick up, let's say you can pick it up here if you want to. Like, it doesn't matter where you pick it. But I'm gonna pick it right here. So what does this mean? This means that the distance from the center or the origin to that stripe is gonna be h. It's gonna be h, the height, which is h. And then the distance from our center to this one is gonna be x, because it's a horizontal distance, so it has to be x. So setting up the diagram is pretty important. I would say it can really affect how you come up with your formula. And now, what is 3 minus h? How did I get this? Well, that's because it is submerged 3 meters here. It says 3 meters under the water surface, which means that the distance from here to here is going to be 3, right? The water level, it goes there. That's going to be 3 right here. And then we know that this is h. So this distance is h. We know that this is h, right? I'm just drawing like this, if it's better. Which means that this right here has to be 3 minus h. It has to be 3 minus h. So the formula is f is equal to the integral from a to b of density times length times def dH. Now, the first step is to find A and B. So what is A and B? Well, let me tell you, A is going to be equal to 3 and B is -5. Now, why is that? If you guys can tell me in the chat, why is A and B like this? Well, because we're trying to find the force from this part, right? We're trying to find a force for that one. Let's see in the chat. Yep, the part in the water, you're right. And the part in the water, where does it go from? It goes from 3, you see here, 3 to -5. And for that reason, B is -5 and A is 3. You're absolutely right. What is the density? Well, we're given the density, and we know that the water is P. The density is P, then this is G, right? So density, if you know in the textbook, is going to be PG. That's simply going to be PG. Now we find the length. The length is this part. It goes from here to here. Let me do it in a different color if it's easier to see. It goes from here to here. That's the length of the stripe from here to here. And the length is going to be, let me tell you why, it's going to be 2x. Because we know that this is x, so this part is also x, and x is 2x. Now, our integral is in terms of h, so somehow we have to convert this to an h. And let me show you how to do that. Okay, there's one question in the chat, 2x, yeah, you're right. So what is the formula for a circle? You might have learned in high school that the formula is going to be like this. X squared plus y squared is equal to r squared. That's going to be the formula for the circle. Now, instead of y, we define this to be h, because that's what the question wants. So instead of y, we're going to write h. And instead of r squared, we know that the radius is 5 meters, right? So 5 to the power of 2 is 25. This thing's going to be 25. So x squared is going to be 25 minus h squared, and x is going to be the plus minus of 25 minus h squared. So you see how easy it is? And how do we know which one to choose? Like, that's the plus sign, that's the minus sign. Which one to choose? Well, it's very easy. The length has to be positive. Right? You say, let's say from your house to your school, it's 2 kilometers. It has to be a positive number. It can't be a minus sign. It can't be a negative number. So this is going to be the positive one. We're taking the positive one. And therefore, we know that x is this expression, which means it's 2 times 25 minus h squared. Let me write the number 5 again. It's going to be like this. And just plug it back into our formula. So the length is going to be 2 times 25 minus h squared. The last step is to find the depth, and that would be it for this problem. So the depth of our stripe. So let me show you where the stripe is again. The stripe is from here to here, which means the depth is from here to here, because it's like the depth of the stripe under the water. So the depth is just 3 minus h. It's going to be 3 minus h. And that's it. If you just solve this integral, that would give you the work. However, on the last year midterm, they don't expect you to solve this. Like, if you just get this, then you'll get 4 marks, unless they tell you you have to solve it and get the final answer. Okay. Now let me ask you guys one thing. Would you guys like me to solve this one? And are there any questions about how I came up with this formula? I'll be happy to solve this for you. It might take 10 to 15 minutes. Okay, let's see in the chat. Okay, so how did we get the depth? How did we get the depth? Well, let me explain that again. So where is our horizontal stripe? The horizontal stripe is this right here, right? That's the horizontal stripe. The depth of the stripe is from here to here. And we already said that it's 3 minus h. 3 minus h. So it's basically how much it is underwater, our horizontal stripe. So that's how you get 3 minus h. Would this be a same approach if it was a semicircle? Yeah, it would be. In fact, like you can just divide by 2 if you get the force, and then if it's only half a circle, you can divide by 2. Okay. Is there a way to use similar triangles in this one? I don't think so. I think this is the only way. In fact, I mean, it's the easiest way to do it. Okay, so looks like there are no more questions. If you guys want, I'll solve this at the end of the workshop in case they ask you to solve this, and it can take a little bit of time. Okay. Oh, there's one question. You know what? I have no idea if they're gonna ask you to solve this on the exam. Like they might. There's a chance they might ask you to do it. Okay. So you guys want me to go over this one or not? In the chat, just let me know yes or no, and sure, right? Okay. I'll go over this one at the end of the workshop. Okay. And now we're gonna move on to the last question of the day. The last question. Question number 9. Oh, and not this one. Okay. It says, well, wait, just 1 second. Instead of putting it there, I'll actually put it to the top because I'll get more space that way. There we go. So question 9 says, a plate takes region R between the graph of y is equal to sine x and the x-axis between this interval. So assume that the density is P is equal to 1. We gotta find the centroid of R. So what is this trying to say? Well, let's say you have the graph sine x. It's gonna be like this, right? It's gonna be like this. And of course, if you know about the sine graph, this is going to be 0. That's going to be pi over 2. And the centroid is like the center point. So it's going to be somewhere here. I'm pretty sure it's going to be somewhere here. That's the centroid. Yep, we're going to go over the cylindrical shell method later. So what are the formulas to find the centroid? I'm going to write it out here. It is going to be x like this is equal to 1 over a. And then b, this is a, that's going to be x. This is f of x minus g of x dx. Now what is y going to be? Y is equal to 1 over 2a. Then you get the integral like this, then fx to the power of 2 minus g of x to the power of 2. And this is actually in brackets, if that is easier to look at. It's going to be dx. The first step is to find the area. So the area is going to be the integral from 0 to pi over 2. This is going to be sine x dx. So that's the area under this graph from here to here. That's the antiderivative is negative cos x. Then it goes from pi over 2 to 0. that is the same as negative cos pi over 2 plus cos 0. And this is just the work for the calculator. So just put that in the calculator, you get 1. So the area is equal to 1. Are there any questions? Okay, you guys okay with this? I found that the area is equal to 1. Okay, so that's our area. I'm going to put it up here. The area is equal to 1. Are you guys okay? I'm going to erase this. Okay, so A is 1. We're going to remove this. Just put 1. And then 2 times A is 2 times 1, which gives you 2. I mean, this formula isn't so hard to memorize. Someone asks how to memorize it. It's just like you see here, this f of x minus g of x times x. And then here is like fx squared minus gx squared. So it's pretty similar to each other. Just try to memorize it. And then what is a and b? Well, this is a, that's b. So let's fix this integral. This is 0 pi over 2, 0 pi over 2. And then what is f of x and what's g of x? Let me draw this diagram again. Actually, I'll draw
Sorry,
it.
before you go a little further, I just have a question. I think I missed your part. Where did you get capital A? And then how did you get like the 1/1 and then the 1/2 specifically
okay.
for the, just if you could reiterate that really quickly, thank you.
No worries. So let's see. So before this was a, right? And then this was 2 times a. That was the formula before I plugged in the a. This was a, and then this was 2 times a. So the first thing is we have to find a, and a is the area under the curve. So the area under the curve was sine of x, right? It's going to keep on going, but it doesn't matter because we know that the boundary goes from 0 to pi over 2. This is 0, that's pi over 2. So that's the area we want to find. That area is equal to the integral from 0 to pi over 2 sine x dx. To solve this, you get 1. Is that right? You will get 1. And then 1 is the area. So what is 1 over a? 1 over a is just 1 over 1, which is 1. That's just going to be 1. What is 1 over 2a? 1 over 2a is going to be 1 over 2. In fact, like it's just 1 times the integral, so we don't even need to write the 1 anymore. Okay, does that help?
Yeah, that makes a lot more sense. Yeah, thank you.
Okay, perfect. Okay, let me erase this. Now, what is f of x and g of x? If you guys remember the curve, right? If you're trying to find the area under 2 curves, it could be like this from the last workshop. Then f of x is going to be the function out at the top. The function out at the top is f of x. The function that is below it, that's going to be g of x. And because of that, we know that this is going to be f of x. It's the function of both. So f of x. And then the function below it is just y is equal to 0, right? That's the function. The function g of x is equal to 0 because it's literally on the horizontal line, right? So we found our f of x and g of x. All right, first I'm going to solve for this one, okay? So x is equal to integral 0 pi over 2. This is 0. Oh, I mean x times f of x is going to be sine x minus g of x is 0 and d of x. That's the same as 0 to pi over 2 x times sine x dx. And I'm going to save you some work, okay? Because this is pretty simple. You'll get 1 for this one too. You will get 1. You guys have to do integration by parts with this one. but I'll save you the work. That's going to be 1, which means that this up here, this whole thing will be 1. Now let's find the y prime. So y is equal to 1/2 times 0 to pi over 2. Then f of x to the power of 2 is going to be sine to the power of 2 of x minus 0 to the power of 2, because g of x to the power of 2, right? So that's going to be 0. And then you have dx. This one's going to be pi over 8. So let me erase this. This one is going to be pi over 8. And the answer, the final answer, the centroid will be, it will be 1 pi over 8. So this point is the centroid, and that's going to be, let's see, that's going to be somewhere here, I'm guessing. Okay, are there any questions? This is all of the questions for today's workshop. So the time is for you to ask questions.
I'm just
Where did
curious.
Oh, yeah. Okay, so someone asked in the chat, where did P factor in again? Could you guys like tell me what did you mean by P, the P factor? The density. The density. You mean from the last problem, right, Joshua? Okay, I'll go over the density in a moment, but someone else asked if you have time, could you go over the general setup of this question? You mean the general setup of question 9, right? This one right here? Like how to set up the question or the formula? Okay, let me show you how to set it up. Okay, so you meant the other question. Okay, quick question, where when it comes to this washer method, how do we adjust when the axis rotates? It's not around 0, okay? No worries, no worries. So Samson, Siri Samson, I hope I pronounced your name correct. I'll answer your question first. You mean in which question?
Sorry. I sent in another question. It's like a volume question, but it has a different shape.
Okay. I see. For questions about cylindrical shell and things like that, I will answer later, because now someone asked about the P factor from the hydrostatic force question. That's more of a priority because those ones seem to be more challenging. Yeah. So Joshua, did you mean this one? You mean how did I get PG, right? So the density is going to be P and the acceleration is G because it's a given to us. So the formula is going to be like this: density times length times the depth. So the density is PG, and the rest I already explained it. So you just use this, just try to remember this, and you can get the formula to solve it. For the centroid question, where do you use density? It's very easy. So I went through this question already, and the density is 1. As you can see here, the given density is 1. Let me show you the original question. Here, right? The density it says is 1. So you can assume that it is equal to 1. So you're asking where is the density used? I'm pretty sure that there's a PG here somewhere. So it's like, not sure how to explain it, but if you look at the formula in the textbook, I don't remember exactly what the formula was, but if you look in the textbook and you can remind me, it's, let's say x like this is equal to 1 over a times b over a, f of x minus g of x something. And then I remember that the PG was somewhere in front, okay? But in this question, like they said the P is equal to 1, so you don't have to include it in the beginning because it's just 1. Are there any specific formulas you recommend writing down? Yeah, it would be this one, but also check with the one in your textbook to make sure. I mean, I know that this is the correct answer because when I did this last year, this was the correct solution.
Wait, could you go back up to the equations again? I want to screenshot them really quickly.
Yeah, this one.
No, the one you showed on the answer key, like the equations for the centroid. Yeah, there we go.
Oh, this is posted on Discord. Yeah, it's posted in the announcement in the Discord.
Awesome.
Was last year midterm similar to the practice midterm given? I would say yeah. Okay, do you mind do a random string pulling question? I believe I already did one. I can send you the link later. I'll send you the link. Okay, so this is what I'm gonna do. I'm gonna put it in the chat here. For questions about cylindrical shells, string pulling. It's actually spring, not string. It's spring pulling questions, dishwasher method. I will post in Discord's MIT announcement. I will post the link because I already went through this. So I'll post the link, okay? So no worries. There's a link that I completely explained and I went through, I remember 5 to 6 questions about these topics and you guys can just watch that. It's actually very short. It's only like 50 minutes. So I remember one person asked about this question. Would you guys want me to go over this one? Finding the work? Okay. Okay, for the dishwasher, don't worry, I'll post the link because I went through an entire question on it. Okay. If I go over this right now, it's gonna take more time. So I'm gonna post it in the Discord later. And the recording will also be posted in the Discord announcement. Okay, the last problem we're gonna go over is this one. Because it seems like in the chat, some people want to go over this one. So let's go over this one. So a tank is of shape of a triangular cylinder lying horizontally 2 meters under the ground in the following figure. So we have this one. It is filled with oil of the density up to 4 meters deep. That basically means it is filled with oil up to 4 meters deep. Okay, I'll explain what it means later. So let G be the acceleration, and we also know it's P here. So you guys don't have to use any numbers. Like we can assume it's going to be P and G, like last time. So we need to find the work. Need to pump oil out of the tank to 1 meter above the ground. Now the formula is work is equal to the integral from A to B of density times distance times area. And let me just show you how to get the equation. So you see here, you know that the nozzle, we have to pump water out of the nozzle, or rather the oil out of the nozzle. We have to pump the oil out of the ground as well, because we are currently 2 meters under the ground. So we got to pump it out of the ground as well. Now, the first step, what's in the chat here? I mean, good luck on the midterm at 8:30 tomorrow. So the first step is to put the x-axis at the top of the shape like this. Just put the x-axis at top of the shape. So this is the x-axis, and you put the y-axis running down like this in the middle. So you run it down. This is the positive y direction. So what are we going to do next? Well, we know that the center is going to be 0. This point is 0. And then this point is going to be 5. Now, why is it 5? Because we're given the height is 5, right? Because of the height, which is 5, then we know that from here to here is 0 to 5, because the height is 5, right? So this is going to be 5. And what else are we going to do? Well, we know that the tank is filled with oil up to 4 meters deep, which means that the distance from here to here is 4. That's 4 meters deep. And because this is 4, we can deduce the fact that this is going to be 1. This point is 1. Because 5 minus 4 is 1, right? It's pretty obvious. So this is 1. So what is A and B? Well, A is 1, B is 5. Because we want to pump all the oil from 1 to 5. We want to pump all of it out of the tank. So this is 1, that's going to be 5. Okay. And now we're going to pick a cross section. We're going to pick a random slice of oil to pump to the top. We're going to pick this one right here. We know that the distance from the center to this point is going to be y, because it's a vertical distance. And the distance from here to here is x, because it's a horizontal distance. Okay, there's a question in the chat. Okay, I'm going to show you a secret to not use the similar triangle. That's a way easier method. Actually, I don't recommend using the similar triangle method because it doesn't work for this case. It doesn't work for this case right here. If you have a tank that's like this, it's not going to work, the similar triangle one. So what's the density? Well, the density is just going to be PG. That's just PG. What is the distance? Well, we want to pump the water. The distance is going to be y plus, we want to pump it to the top of the ground, which is 2. So we plus 2, because we got to pump it to the ground. So that's why we plus 2. And then we're going to pump it out of the nozzle too. And the nozzle is 1 meter, so plus 1. So the distance is just y plus 3. That's going to be y plus 3. How about the area? The area is very simple. Now, in the textbook, they use the similar triangle method. But instead of using the similar triangle, I'm going to use a different method, which is the y is equal to mx plus b. It's way easier. Now, we know that from here to here is 4, right? They give you the number 4, which means from here to here is 4. And we have a we have the horizontal axis and vertical axis like this. So because this is 4, then from here to here is going to be 2, because it's half of that. So this point is going to be 2, 0. And this point is going to be 0, 5. I think finding this is pretty easy. So we get 2, 0, then 0, 5, then 5 minus 0, 0 minus 2. That's going to be negative 5 over 2. It's going to be, yeah. Okay, so this is going to be negative 5 over 2x plus b. Then we plug in, we're going to plug in one point. We're going to plug in this one. So y is 0, and this is going to be -5 plus b, so b is equal to 5. So the equation is going to be y is equal to -2 over x plus 5. That's our equation. And we're almost done. We're so close. At this point, you are very sure that you're going to be finished soon. So the area of our cross-section, the cross-section is here. Remember, don't forget, this is the area of the cross-section. It's going to be a rectangle, okay? That's a rectangle. Because if you're standing here, and you look down, what shape is that going to be? Can you guys tell me in the chat? What shape is this going to be? It's a rectangle, okay? Last workshop, some people said a triangle. It's not a triangle, it's a rectangle. So this is going to be the area, which is base times height. Now the base, let me get rid of this. That's much better. So the base times height. The base is from here to here. The base is from here to here. Now we know that half of it is x, right? So the entire base is 2x. And the height is from here to here. And we're given the height as 10. The height is 10, we're given it. So times 10, that's going to be 20x. Now we can use this equation to find x. So I'm going to save you the work. So x is going to be 2 over 5 times y minus 5 minus y. So this right here is going to be equal to 2 over 5 times 5 minus y, and we found the area. Okay. Give me 1 second. Give me 1 second here. Actually, this is 20 times. This is going to be 20 times x. And x is 2 over 5 times 5 minus y. And so this is the same as 8 times 5 minus y. So the area is just 8 times 5 minus y. And that's it. If you come up with this on the last midterm, this is the correct answer. Now, are there any questions to how I find any of this? Now, just for fun, if you want to solve this, you'll get this number times BG. Okay, 8 questions in the chat. Yeah, so y plus 3 is the distance the oil has to go. So where did y plus 3 come from? Well, it has to get pumped to the top of the tank, and that distance is y. That distance is y. We have to pump it out of the ground. We are 2 meters under the ground, so plus 2. And then we got to pump it 1 meter out of the nozzle, so plus 1. And that's where we get y plus 3. Okay. And that's a question about let's see, what's your question again? Can you show the y is equal to mx plus b method for another shape? Yeah, I can. That's where the bounds come from. The bounds, we keep it as small as the biggest. So you mean the boundaries like this? Like where does this come from? Is that what you're talking about? Okay. That is actually very simple. So we need to pump all the oil out of the tank, right? So we determine that this point is 1, and then this point is 5. So the oil goes from 1 to 5. So that's why we just need to integrate it from 1 to 5. And then for the y is equal to mx plus b, you would like me to go over a different problem. And I don't think I have any problem here. Like I don't have another problem at the moment that I can go through, but I can tell you that it works for this one. For this one, you can also do the same thing. Like you have this right here. And then you can also find, you can just take these two and you can find this equation and just plug it back into the area formula. It is the exact same method. Okay. It's the exact same method. The only difference, the only difference is that the cross section, instead of a rectangle, it's gonna be a circle. And the circle is pi times r to the power of 2. Right? And because this distance is x, you can write it as x. So this is x to the power of 2. And then you just need to change this in terms of y. So you can use the y is equal to mx plus b, find these 2 points, plug it in, solve for x, then you get the y. You just put it back into the formula. Okay, so I'd like to say thank you for coming. I will post this recording on Discord, and I will also post the link for the problems that I went through about the cylindrical shell, the dishwasher method, and also the spring, pulling the spring to get the work. I'll upload these recordings and also the links onto the Discord announcement. Okay, thank you everyone. Have a nice day. Good luck on the midterm tomorrow.